Good day. Today we'll be looking at static electricity. Now, static electricity is something we experience. Almost everyone would have experienced static electricity in some way. Now, the most common form, the most observable form would be that of, say, lightning. So everybody should know what lightning is, but let's first define what static electricity is. Now, static electricity is the buildup of charges on the surface of a material. So let's just write that down now. That static electricity are the keywords buildup or accumulation So this is basically what static electricity is. And we have two fundamental charges. So when we speak of charges, we speak of positive and negative charges. So we may have a buildup of positive charges on one material or negative charge. Now that leads us to ask the question, where do these charges come from? Now, all matter have one thing in common, that they are made up of some tiny particles we call atoms. Now this diagram that I'm going to draw is a very simplified diagram of what an atom looks like. Right? Let that stay. And I'll go ahead and just label the atom before speaking on each part. I'll just erase this ring just so our diagram doesn't get too big. So we can work with these two rings here. So this atom consists of electrons, protons, and neutrons. And these rings here we can call them electron shells. So these are basically regions or these paths or areas we can find electrons. So let's label these X's here. So electrons are normally paired. Only on the first shell you may have two electrons only on the first shell. So we say these are electrons. The electrons orbit the atom in electron shells. These shaded spheres, I'll make them the protons. The unshaded spheres, circles, I'll make them the neutrons. Now the protons and the neutrons, they exist within the nucleus of the atom or the center of the atom, while the electrons, they orbit the atom on the outside. So here, I will call this the nucleus. Now, as we get back to charges, these subatomic particles, the electrons, the protons, the neutrons, they all have their respective qualities. Now, in terms of charge, we're looking at charges. Protons, each proton has a relative charge of +1. An electron has a relative charge of -1. Now a neutron is pretty special. It has no charge. So it is neutral. It is neutral. Now we'll take a look at that. All right, so let's move on a bit. When things become charged, we know it's either due to the amount of electrons it has or the amount of protons, the net amount of electrons or the net amount of protons. Now, we said that electrons are negatively charged. They have a relative charge of -1. Protons are positively charged. They have a relative charge of +1. Now, there is one special method we'll be looking at as we seek to make something become electrostatically charged. And that is charging an object by friction. Charging by friction. We'll be looking at that today. Now, charging by friction, as the name suggests, requires some frictional force, some frictional activity, some rubbing of materials or surfaces of materials. Now, if all matter has atoms, that means all matter has electrons and protons. We'll be looking at a simple pen. Everyone should have a pen, so this is my pen here. It's a special type of pen. And we'll look at, say, your uniform fabric, your school uniform fabric. Now, naturally, all materials in our environment are neutral. So things don't appear charged naturally in the environment. They have to become charged by some process. Now, the process we're looking at is charging by friction. Now, all materials have protons and electrons, but only the electrons are able to move from the surface of one material to another. So how does that work? As you would have seen in your handout, if I have a piece of cloth, I'll be using my shirt sleeve here, and I have this pen. I can rub this pen on my shirt sleeve to get this pen charged. Now, based on the material, the two materials that you're rubbing together, one will become negatively charged and the other one can become positively charged. Now, in the case of this pen and this shirt that I'm wearing, if I should rub this pen on my shirt, let's see what will happen. So before, the pen is neutral, so it has equal amounts of electrons, equal amounts of protons, and also my shirt is neutral. So equal amounts of protons, equal amounts of electrons. So they cancel each other out. However, when I do rub them together, when I cause some friction, we know that friction generates heat. Now this heat gives the electrons extra energy. Now the electrons that are on my clothes, my shirt, they will get so much energy that they're able to transfer from the surface of my shirt to the surface of my pen. And if I should draw that, we're going to have the electrons moving. So these are our electrons, the negative signs. They're going to move now over to my pen. Let me just see if they're equal at first. So before, I have 1, 2, 3, 4 protons. 1, 2, 3, 4 electrons. 1, 2, 3, 4, 5, 6 protons. 1, 2, 3, 4, 5, 6 electrons. So they are neutral now. But as I said, the electrons are now going to jump once they get enough energy through the heat generated by friction to jump to the surface of my pen. Now the only electrons that will move are the electrons that are on the surface of the material. So how many electrons are here? We have 6. Not all 6 need to jump over, but let's say that 4 of the electrons here be transferred to the surface of my pen. So let's do that now. And draw a diagram to represent that. So this is the same pen I have over here. I have 1, 2, 3, 4. 1, 2, 3. Let me spread them a bit. All right, so 4 protons. I initially had 4 electrons, so put those 4 electrons back. 1, 2, 3. Need another one. 4. However, I said that 4 extra electrons will now jump from my fabric over to the pen. So I'm going to put one right here. 1, 2, 3, 4. And I check them as far as possible from the other electrons that are here, because like charges tend to repel. Like charges repel, unlike charges attract each other. Now here I have my pen. My pen has a negative charge because it has 4 more electrons than protons. So it is now negatively charged. Why is it negatively charged? It has more electrons than protons. Negatively charged. Consequently, my fabric right here becomes positively charged. Anybody knows why? That is right, because it loses electrons. Now it has more protons than electrons. How many protons? 1, 2, 3, 4, 5, 6. So it has the same amount of protons it had before, because protons don't move, they stay with the atom. How many electrons does it now have? It had 6 initially, and 4 went to the pen. It now has 2. So it has a net, an overall positive charge. So we say this is positively charged. All right, take a minute to look at that. All right, so that was a good minute. We're going to move on. We're going to do a little experiment. Before we do experiment, I'd like to just draw the diagrams. Now that same pen that we just broke is negatively charged. It has a net negative charge, so more negative charges, more electrons than protons. 1, 2, 3, 4, 5. So that's good enough. So it is negatively charged. What do you think would happen if we should bring this pen now close to a piece of paper? Now this piece of paper is just lying on the desk, so naturally it is neutral. It has no charge on it. So if it is neutral, neutral simply means, in this case, equal amounts of electrons and protons. And we are looking at those that are on the surface, the atoms that are on the surface. So let's count, just to ensure that we're right on track. What I'll do, negative, positive, negative, positive. Yes, I try to alternate because we know that like charges tend to repel each other, unlike charges attract. Now, this is our piece of paper. Let me label it. Paper, a small piece of paper. What do you think will happen if we should put this negatively charged pen close to it? Draw that diagram over here. So we know our pen has 4 more electrons than protons. So it has a net negative charge. All I'll do, I'll draw those 4 electrons, the negative sides to represent the 4 electrons that it has more. And this is my paper. What do you think will happen on the surface of my paper? Think about that. You are correct. Now, what will happen is that unlike charges will attract, like charges will repel. So the electrons would move, not the protons. So the electrons that are on the surface of this paper, they will seek to move as far as possible from this negatively charged pen. So we have 4 electrons, all 4 electrons will seek to move as far away as possible, thus exposing the atoms with just the protons in the nucleus. So just the protons are now in the nucleus. The electrons have kind of moved away. Unlike charges are close to each other now. So the electrons are back this side, far away from the negatively charged pen. Now they have exposed that positively charged nucleus to our negatively charged pen. Now, unlike charges will attract. And let's see if we can actually do this in real life. All right, so I need to first charge my pen via friction. This is a piece of paper that I'll be attracting. So let's see if that is possible. So this is the paper. Let me just put it to the side here while I charge my pen. Hopefully this works. Give it an initial rub. Let's go. All right, look at that. So the pen has attracted the paper. It's not magic. It's science, it's physics. Now, static electricity is used in many industries. For homework, you can look up some, Some examples are in printers. We have factories all around and they let out a lot of fumes in the atmosphere. So what will happen many times to decrease the amount of fumes going out in the atmosphere, the grills that they put over the, what can we call them, chimneys, yeah? The grills that they put over them can be charged to attract the smoke, some of the smoke that is escaping. Also, we use static electricity when we're painting cars, spraying cars, right? So the paint will stick to the car. We use it when we are printing documents on printers. Use that technology to ensure that the ink sticks to the paper. And there are other applications that you can also research for yourself. So thank you. Next topic we'll be moving on to is current, electricity, right?